students, welcome back to my class. The series of learning programming in C. In the previous video, we discussed about a program on 2D array, that is row sum and column sum. In today's video, we will discuss about how to find the product of two compatible matrices. Compatible at the same time complex. See, can you able to see here how much complexity is involved? Let us see how to reduce this complexity, how to understand this. So those who are new to my channel, please subscribe to my channel and click on the bell icon so that you can get the notification of all the new videos. And if you like the video, please click on the like button and share the video to all your friends. Product of two compatible matrices. The name itself tells you compatible means. Here we need to understand what is the meaning of compatible here. So here when I say the product of matrices, it is quite different from sum of matrices. Sum of two matrices is very simple, but product of two matrices is quite complicated. So how to find that product of two matrices and what is compatible means to say, let us see. So first of all, before we get into the program, we have to know how actually we do the product of two matrices. So here we have two matrices here. This is matrix 1 and this is matrix 2 and this is what the resultant matrix. Well, you can just observe the order of the matrix is different here. See, here it is 2 cross 3 and here we have something called 3 cross 3 and the resultant is once again in 2 cross 3. Now we need to understand what actually the compatibility is. Compatible matrices in the sense, some different technique is involved in the product of matrices. What is the technique that we need to see, and then we will understand why this meaning compatible is used here. Okay. Now, so what we do here in the matrix multiplication, we have two rows here. The first row of the first matrix has to be multiplied with the first column of the second matrix. First row of the first matrix gets multiplied with the first column of the second matrix. So how we have to do? This complete row, we have to bring it here like this. Say 1, 2, 3 elements are written. This row to be multiplied with first column. So when I am bringing with the first row with first column means to say the number of columns here that what I have in the first matrix should be equal to the number of rows in the second matrix. I'll repeat here. The column of first matrix should be equal to the rows of second matrix. Columns of first matrix should be equal to rows of second matrix. So what is columns here? How many columns we have? It is 3. How many rows we have? It is 3. Columns of first matrix 1, 2, 3. Rows of second matrix, it is 1, 2, 3. That is what the meaning compatible. So here compatible matrices in the sense the column of the first matrix should be equal to the rows of the second matrix. That is what compatibility means here with respect to product of matrices. Here when I bring this complete row to this column, I should have the equivalent row also here. The first row I have to bring it here and multiply with first column. So when I bring the first row, all the column values I will get. So this column should be equal to the rows here. See 1, 2, 3 I'll bring it here means I should have the respective rows here, right? That is what the meaning. Number of columns of first matrix should be equal to number of rows of the second matrix. So when I bring that complete row here to the first column, I should have the respective rows, right? So here I have 3 columns means I should have 3 rows. If there is no row here, then I just can't do the multiplication. That is what the meaning of compatible. So let's proceed now. Now, first row of the first matrix, I have to bring it to first column. So what I'll do here, I'll just bring this values here 1, 2, 3. So I have to multiply this with first column. First row of the first matrix to be multiplied with first column. So I have to say it is 1 into 2 plus 2 into 2. I have written here itself. I can just do like this also. Plus 3 into 4. So it is 1 into 2 plus 2 into 2 plus 3 into 4. So it is 2 plus 4 plus 12. How much? It is 12 plus 4, it is 16. 16 plus 2, it is 18. So this is what the first value I am going to get. So that I am going to store in the resultant matrix. So here I'll get 18. Right? The same way, this first row of the first matrix should be multiplied with first column, second column and third column. First column I am done. Proceed with second column. So I should say again 1 into the same row. 1 into second column into 5 plus 2 into 1. You can simply bring it like this so that you can do the multiplication easily. So it is 1 into 5 plus 2 into 1 plus 3 into 1. So it is 5 plus 2 plus 3. How much? It is 7 plus 3, 10. So my next value, it will go to the next cell. Again, one more column you have, right? The first row to be multiplied with first column done, second column done, third column I need to do. So I have to say 1 into 1 plus 2 into 1 plus 3 into 3. So it is first row, first column done, second column done, third column. 1 into 1 plus 2 into 1 plus 3 into 3. So it is 1 plus 2 plus 3 3s are, it is 9, 9, 10, 12. So my next value is 12. I have to go with second row. First row, all 3 columns done. Second row, all 3 columns I need to compute. So it is 4, 5, 6. So I need to write 4 into 2 plus 5 into 2 plus 6 into 4. So it is 4 into 2, 8 plus 5 into 2, 10. 6 4s are 24. 24 plus 10, 34. 34 plus 8, it is 42. 34. 34 plus 8, it is 42. That I have to store here. Row 1. Next, again this second row with second column. So I need to say same thing, 4 into 5 plus 5 into 1 plus 6 into 1. So 4 5s are 20 plus 5 plus 6. 25. 25 plus 6, it is 31. That I'll get here. Again, this second row with third column. So it is 4 into 1 plus 5 into 1 plus 6 into 3. Am I right? 4 into 1, 5 into 1 and 6 into 3. So it is 4 plus 5 plus 6 3s are 18. 18 plus 5, it is 23. 23 plus 4, it is 27. That I am going to print here. Then all 3 columns done. Get back to this. Do we have one more row here? No. If you have one more row, then again that row with all the 3 columns. So this is what the output I'll get. And see, the output will be in the format of the first matrix here. Right. If it is 3 cross 3 also the same thing, it will be the 3 cross 3 because first matrix. But one thing you should remember, the columns of the first matrix should be equal to the rows of the second matrix. First row, all columns. First column, second column, third column. Then second row, first column, second column and third column. When you bring the first row to the first column, you need to add up the values. See, for example, here it's a second row. So it is 4 into 2 plus 5 into 2 plus 6 into 4. That will be the complete value. That will go to one cell. Then again, the second row with second column means it is 4 into 5 plus 5 into 1 plus 6 into 1. That is the next value. You need to multiply that. And again 4 into 1 plus 5 into 1 plus 6 into 3 becomes the next value, like that. So this is what the product, or what we call it as multiplication of two matrices. The actual program of this we will see in the next video. So stay tuned to my channel and watch the complete program of this product of two matrices. That's all for today's video. See you in the next video. Till then, take care. Bye-bye.